Hello everybody, welcome to the first series of promotional videos for CIBS, that is the Center for Integrated Building Systems, the director for which is Dr. Craig Bradshaw.
The Center for Integrated Building Systems is focused on how to make better buildings, and specifically how to make better equipment that integrates directly with the buildings. The building of tomorrow is going to be designed very different than one designed decades ago. It has to account for things like how are the occupants going to use the space, how does the equipment most efficiently use the energy, and how does it integrate with the environment and the grid really efficiently.
We have lots of equipment and infrastructure that supports CIBS. This includes a pair of psychrometric chambers that are housed in the Advanced Technology Research Center building on Oklahoma State's campus. These are state-of-the-art facilities that were constructed by students over the course of about 5 years. They can house units up to about 20 tons of air conditioning capacity. That's how much heat is being removed from the units themselves. They are large enough to fit commercial-sized rooftop air conditioning units into and have very unique airflow capabilities that most academic institutions do not have. We've used these pair of rooms for a plurality of projects, including unit testing, component testing, and everything in between. So we're really excited about how these units can be, or how these facilities can be used to support CIBS as we move forward.
The chamber is split into an outdoor room and an indoor room. Currently we are standing inside the outdoor room here, and while on the other side is the indoor room. This makes sure if you want to test a split unit air conditioner or heat pump, you can keep the outdoor unit in the outdoor room while you keep the indoor unit in the indoor room. So our facility has the capability to test 20 units with a cooling capacity of up to 20 tons. It can cover relative humidity in both the rooms from 10% up to 90%. The outdoor room has the capacity to generate sub-zero temperatures, so we're talking about minus 40°F, and it can go up till 130 degrees Fahrenheit. While for the indoor room, where our requirements are not that stringent, we can still achieve between 50 degrees Fahrenheit and 100 degrees Fahrenheit in temperatures. And we have an airflow circulation capacity of approximately 8,000 cubic feet per minute. I would like to point out here that the psychrometric chamber facility is able to achieve the air side inlet conditions, that is temperature and relative humidity, by a combination of electric water heaters, a chilled water loop, a set of fans, and a steam generator. Behind me here you see a combination of 3 different bays. Bay 1 and Bay 3 are identical to each other, and these house majority of the conditioning equipment, where the central bay houses the airflow measurement device. I will also like to point out here that this facility can be controlled remotely via Labview as the main software, and we have several thermocouples, pressure sensors, and relative humidity sensors for which data is transmitted in real time.
We have dedicated Labview program to control this chamber and fluid loop as well. Let me briefly explain. This is the Labview controller. So we have a nozzle box, blower, so we can control the airflow rate, and then we have a cooling coil, so we can control the cooling water flow rate, also the temperature, and then we have a heater, and then we have a humidifier, so we can control the humidity and the temperature at the same time. And this is the controller of the fluid setup developed by Saad Salim. So there is a pump speed controller, for example, heater controller, so that we can control the temperature and pressure, certain condition of the refrigerant side. That going through the test section. And then we have the dedicated display that's showing in situ all of the temperature and pressure and the flow rates variation, so we can monitor, so that we can control our test conditions. I'm also happy to report we have a lot of DAQ boxes that can accommodate a lot of sensors. For example, we have 8 DAQ boxes in the indoor chamber and outdoor chamber, and then outside the chamber as well, and that contains a lot of RTD sensors, and then in and out ports can accommodate 4 to 20 milliamperes, such as, and then 0 to 10 volts. As you can see, we have a lot of thermocouples. So we can say this psychrometric chamber can perform a lot of different projects at the same time as well.
Right now we are in the control room for the chambers. So behind me you can see the data acquisition system. Basically this is the central hub where all the information that we gather from the chambers travels through these terminal blocks from National Instruments, and all of this information eventually goes to a computer that has the sole purpose of controlling Labview remotely.
I'd like to introduce this ductwork. So this ductwork serves 2 projects, the CIBS project and the Azure research project. So this is the heat exchanger test module. So this is a unique part. We can test, so that we can observe thermal fluid characteristics, and then also we can measure the refrigerant charge inside this heat exchanger. For example, so this module is a removable charge heat exchanger test module. So this is the heat exchanger, the plate fin heat exchanger. So this can be removable, and then this can be connected using quick clamps. So by doing so, we can make it airtight. So the airflow coming from the inlet duct and then going through the heat exchanger module. After the heat exchanger, the airflow going through the nozzle box to measure the airflow rate, and then airflow going up and divided into 2 streams, and then going to the cooling coil, and then it's cooled down, and then we have a separate heaters. So it's going up at it can be, the temperature can be controlled, and then we also have a humidifier, so the humidity also controlled. So the temperature and the humidity controlled airflow going down and then coming up from the floor, and then it can generate the uniform airflow, and then it's going up to the upper ceiling plenum, and then the airflow rate is circulating, keep going on. This is the unique feature of this psychrometric chamber, and this is the ductwork. Let me explain a little bit more about this RHXT. Stands for Removable Heat Exchanger Charge Test Module. Condition the refrigerant is going through this module at the same time airflow and going through. So the refrigerant going down through these pipes, and then there are 4 expansion valves, so the pressure is controlled, and then going through the test heat exchanger, and then the superheated vapor coming out through this pipe. So the conditioned refrigerant going into the module, and then the superheated or other after heat exchanger, the refrigerant going back to the refrigerant loop. And then we have a bunch of instruments to check the pressure, temperature. We have 4 different refrigerant DP sensor to measure the differential pressure, inlet and outlet. And then this one has 2 RTDs, inlet and outlet, to measure the inlet outlet conditions. Also, likewise, we have 2 different high accuracy pressure sensors to the inlet and outlet. Importantly, so we have 2 individual quick shut-off valves, which is placed in inlet and outlet pipes. So we can quickly isolate this module from the refrigerant group by closing these shut-off valves at the same time. As I said, this is removable things. So all the instruments cable can be disconnected easily, everything. So we can measure the mass of this module by removing this from this ductwork, bringing to our dedicated differential mass measurement scale.
All of our facilities were designed with standards in mind. This is an important byproduct of CIBS. So most of the infrastructure is used for the specific research outcomes from the projects themselves, but they can also be leveraged for things like third-party validation. To do that, we need to make sure that our facilities are compliant with all the relevant standards that are there to test equipment. In this case, either units or components that we might test in psychrometric chambers or the compressors themselves.